I want to analyze the space. Okay, so we have done something. If we select this, we know that it's occupied, it's heated and cooled, and then space type. Okay, so we can select what kind of space we are doing here. So if we click here, space type, look at this. We have thousands, a lot of options. So what kind of building we are working with? We can say that we are working with an office building. Do we have office building somewhere? Well, here we have lobbies. Okay, we have lobby. It's a lobby of an auditorium. It's a lobby of a hotel. It's a lobby of the post office, a religious building, office, open plan, office enclosed. I would say that this building, it's an office enclosed. It's not an open plan because we have partitions. Office common activity areas. Maybe this is the best way to define what this is. It's an office building, but it's a common activity. It's not an office where people are working or whatever. So this is a lobby or a, okay, so I would select this one. Why? Because I feel like selecting this, but again, it's your decision. And here we have the area per person. We have 358 square feet per person. Is it? Imagine a lobby. Do we have 350 square feet per person in a lobby? Do you think we have more, less area per person? Less. Well, now there is nobody in that lobby. But I don't know, if there's a meeting there, there are a lot of people arriving at the lobby. We can have more people. So again, this is our decision. How many square feet per person would you say? How many square feet per person do we have in this office? So we have a person here. So how much is this area, kind of? 20. Yeah, I would say 20. So this is a classroom. In a lobby, we are not that crowded usually. Okay, so we can say 100. But it can be 100, it can be 50. It's up to us. But it affects because the number of people affects the ventilation loads. Okay, so here we have to start making decisions. Let's type 100. And here we have sensible heat gain and latent heat gain per person. We have talked about this in Building Science 1 in systems. So if we don't remember the concept of sensible and latent heat gains, okay, go back to your notes or the lessons. But I would rely on these values because it's a heating gain per person. That depends on the activity of the building. So it's not the same in a gym. In a gym, the sensible and latent heat gains would be higher. In a lobby, I would rely on this. Then lighting load density. Again, these are watts per square feet. The watts per square feet is the amount of energy that we need to for the lighting, the artificial lighting in this lobby. So we can check all these values. Again, what's lighting? Okay, I can find out. I can check the specifications of this lamp. I can see how many lamps we have. I can see the power of these lamps, and I can see the area of this room, and I can say, okay, it's 20 watts per square feet. I can find out. But if Revit offers all these activities, it's because, well, we can rely on that. The area per person, it sounded like weird. I can change that, okay? But the rest of the parameters, infiltration, airflow per area. Wow. Infiltration, it's about the quality of the construction. The better the quality, the less the infiltration rate. Plenum lighting contribution. I don't know what that means. Occupancy schedule. So that's nice. You remember if you took systems last semester or last year or whatever, we worked with an Excel file and we created like a schedule. Okay, so we have no occupancy from midnight until 6 a.m. and then we have this value. Okay, we can analyze that. Is this, imagine this building, we're working in this building. Is this true? Do we have anybody working from midnight to 6 a.m.? I don't think so. Maybe at 6 a.m. someone comes here. It might happen, I don't know. But then we have full occupancy. One means full occupancy up to 12. Then we have a break. Then we have the afternoon classes. And then by 11 p.m. we have everybody is out. It sounds good. Okay. But that depends on the, if I select another, yeah, you see that if I select another use, this is a hotel. So in a hotel, it's the other way around. Everybody's in the room during the night and everybody leaves the hotel at noon, kind of, okay? So depending on what kind of, yes. Okay, depending on what kind of activity we're doing here, we have this schedule. Okay, if we want to be thorough, you remember that we did this, we said with an Excel file in systems. We have from 12 to 1, 0% of occupancy or 1% or 2% or whatever. So we can change it. The lighting schedule, it's 7 a.m. to 6 p.m. Okay, we can change it as well. The outdoor, this is important, outdoor air per person. I would change that. What is there's a magic number about the CFM per person that we have to use. What is this magic number? 20. Okay, so when in doubt, 20. If it depends on, again, depends on the use. If we have a gym, probably it's more than 20. If we have a library where everybody's quiet and nobody's talking or whatever, it can be less than 20. But here I would use, okay, so look at this. We have two options, outdoor air per person or outdoor air per area. In this case, they have this number. I would rely on 20 CFM per person, and we can't have both. Okay, so if we have air per person, we don't have air per area. But since I remember that that number, I remember 20, so I would use 20 CFM per person. And here we have air changes per hour. Okay, so we have 3 different ways to introduce the same information. Either the air per person, the air per area, or the air changes per hour. With the air per person and the number of person, I can calculate this one. But if you select one of the options, the others can be 0. Outdoor air method, we can say maximum by people and by area, for example, or maximum by yeah. So let's use this one. Maximum by air changes per hour, by area, or by people. So if we have here 20, 0, and 0, by default, it will select 20 because it's the maximum of these 3 options. Then the heating set point and the cooling set point. Okay, so that means that if we are below 40 Fahrenheit, the systems start working, the heating system. And if we are above 100 Fahrenheit, the system, the cooling system, start working. I assume that those are outdoor temperatures. Is it fine? We can change it. So if you don't like it, go ahead, change it. And then the humidification set point, that means that we have at 0 relative humidity, we start the humidification system. And then if we are above 70, we start the dehumidification system. Okay, that's fine. So this affects, all these conditions affect the system. And we can change all these conditions. So we have control over a lot of things. But again, out of all these options, we have to select something that is closer to the activity. And then we click there, then we can select all these numbers. I will take a look at it. And then if something is weird, I would change it. But if I don't know, if I'm not in the conditions to know about the latent heat gain or whatever, so let's keep it. But that's the good thing of comparing these results with other software. If we're using other software, maybe the assumption of sensible heat gain or latent heat gain is different. Okay, if we just print this list, and if we want to check these results with other software's results, we have to take a look at this checklist to make sure that everything is correct. Okay. So this is it. Let's click OK here. And now we can go to level 0. This is Office 1. So in Office 1, we can select the space type, and this would be Office enclosed. And let's assume that all these options are correct. Okay, Office 2, I can select space type. I can select Office. Which office? Office enclosed. This is a meeting room. Okay, I would select Office enclosed as well. But this was, remember that was a mechanical room. So in a mechanical room, it's not a plenum, because the plenum is something that it's between the false ceiling and the roof. Occupable? No, I wouldn't select this one. Okay, and in the, I would say unconditioned. If there's a mechanical room, because a mechanical room doesn't have a heating system. We have our storage or whatever. Okay, but that's why we can't start placing spaces 1, 2, 3, 100, because then we have to go one by one, checking all these conditions. So when you place 5 or 3, 4, 5 spaces, make sure that you check all of them. And if there's a mechanical room, make sure that it's unconditioned. We don't have a heating system, but this is not outside. With a mechanical room, the same thing applies. If we don't have the space in a mechanical room, that means that this is outside, and the limit between something heated and something in the outside, it's just a partition like this that doesn't have a thermal insulation. So we will be making a huge mistake. If we consider that a mechanical room it's something heated, we are making a mistake, because the heat losses, if this is not heated, will be higher here than between 2 heated spaces. So we are making a mistake, but it's not that relevant. And finally, if we want to be thorough and we want to do things right, then if this is a mechanical room, make sure that you select this condition unconditioned. Probably we can select occupied and unconditioned. Well, yeah, I would do that, because there might be people sometime, there might be people in the mechanical room, not permanently, but yes.